So for number 24, we want to take the area bounded between these two curves, y is equal to x and y is equal to 2x over 1 plus x cubed. And we want to revolve it about the line x is equal to -1. So I've gone ahead and I've put this in a graphing calculator, and the area between them is shaded in yellow, and we want to revolve it about this line. So when we revolve it, we end up with a little section here. And this gets revolved into a cylinder, like so. And so we can think of the volume as adding up all these cylinders from 0 all the way out to 1 where they intersect, right? So if I were further along, like maybe x is equal to 3/4, my cylinder would be way bigger, like so. Right, and then we're just summing up all these cylinders to get a volume. So let me remove that so it doesn't get too crowded. Okay, and so think of each of these cylinders as being like an infinitely thin sheet of paper that gets wrapped around the line x is equal to -1. And so our volume is going to be given by the sum of all these sheets, right, which is going to give us a solid that gets revolved. So we can say here that our volume is going to be the sum from 0 to 1 of ax dx. And ax, because these areas here, the area of each of these sheets, it definitely does depend on x, right? Like the further we are along the x-axis, the wider and wider our base is going to be, like the bigger our cylinder. So we definitely need a way to express the area of each of these sheets in terms of x. So let's try to do that. And remember that the area of a rectangle is just base times height, right? So let's first talk about our height, which is this little blue section here. And as we can see, this blue section is basically just the height of the blue curve, which is the 2x. This is 2x over 1 plus x cubed minus the height of the red curve. So minus this chunk here. So if we take the height of the blue curve minus the height of the red curve, we're going to be left with this little section, which is what we want. And so we can say here that the height is the blue curve minus the red. So 2x over 1 plus x cubed minus the red curve, which is just y is equal to x, right? So minus x. And so that does give us our height. And now let's talk about our base. Well, the base here is basically just going to be this part, right? It's going to be a circle that's the base of our cylinder, and this corresponds to here. And I guess I should have drawn the blue here so that you guys can see how that area is related. And this is a circle, and the base is the circumference. So the circumference is given by 2 pi r of any circle, and we just have to figure out what the value of r is in terms of x, since we're integrating with respect to x. So to find the radius, basically we have to go from -1, and then we have to go all the way out to 0, right? So that's a distance of 1. So from -1 to 0, we have to go a distance of 1 plus wherever I'm at on my x-axis, right? Plus the value of x. So for example, if I were at here, x is equal to 1, I would have to go -1 to 0 and then 0 to 1. So it's just 1 plus, because that's the distance from -1 to 0. So 1 plus wherever I'm at on my x-axis. So this is basically just 2 pi. So 1 plus wherever I'm at, so 1 plus x. Therefore, this area is base times height, which is equal to 2 pi times 1 plus x, that's our base, times 2x over 1 plus x cubed minus x. All right, and that's the value for my area, right? So this just means that wherever I'm at on my x-axis, if I plug it into this expression, that is going to give me the area of a cylinder, and then for the volume, we're just summing up all these areas. So we're going from 0 to 1 of ax dx, and this is equal to, let's see, from 0 to 1. I'm going to put my 2 pi outside because that's a constant, so 2 pi, and then inside the integral, I get 1 plus x times 2x over 1 plus x cubed minus x, and all of this times dx. And now they don't actually want us to integrate it by hand, thank God, because that would be terrible. They want us to just plug it into a calculator, right, to evaluate it. So I'm using the calculator symbol lab, and so when I evaluate this whole thing from 0 to 1, I'm going to get 2.36164, and that's the volume that I get here when I take this yellow line and I revolve it, this yellow area, and I revolve it about the line, x is equal to -1. And so that is it.